Okay, I hope all of you are doing well. Today is our first class, and this is your syllabus. I have already talked about the syllabus in my introduction class. Today, as you can see in the group A part, we have inorganic chemistry, which is of 2 credits. We will have an exam of 50 marks. In this group, in the first unit, you have atomic structure. In atomic structure, we have some points in this syllabus. Now, we have already done this chapter in class 11, but I know we are human beings, so there will be some problems in some parts. So today we will start again from the basics, and the basics are quantum numbers and their significance and all these S, P, D and F orbitals, okay, which is the main part of this atomic structure, that is the unit 1. Okay. The part is quantum number. We all know there are 4 types of quantum numbers. Four types of quantum numbers, which are principal quantum number, which is denoted by n. Then we will have azimuthal quantum number, which is denoted by L. Then we have magnetic quantum number, which is denoted by M. Then we have spin quantum number, which is denoted by S. So these are the 4 types of quantum numbers we will have. Now, the values. Suppose you have the orbitals, like we have to have the orbitals first. The orbitals we know S, P, D and F. There are 4 orbitals, as we know. For S orbital, N is 1, L is 0, M is 0, S is plus half and minus half. For P orbital, N can be 1, 2, L. For n equal to 1, L is 0. For n equal to 2, L is 1. That means L equal to n minus 1. And for M, we have the values like minus 1, 0 and plus 1. Because the maximum value of L is 1 here. So the formula is minus L to plus L. Minus L to plus L, that means minus 1 to plus 1. For d orbital, and again I will come back here. For every value of M, there are 2 values of S. One is plus half, another is minus half. This will continue like that. Okay. For d orbital, we have n equal to 1, 2, 3. So L should be like that: 0, 1, 2, and M minus 1, sorry, minus 2, minus 1, then 0, plus 1, plus 2, and for all the values of M, we have two values of S, which are plus half and minus half. And for F orbital, we have the value of N equal to 0, 1, 2, 3. So L, the value of L will be like that: 0, sorry, there's some mistake done. 1, 2, 3, and 4. And for L, we have 0, 1, 2, 3. And for M, we will have minus 3, 2 plus 3. So this is our orbitals and the relation between orbitals and quantum number. Okay, I hope you all understand, and if you want, you can take the screenshot. Okay, now we have some topic like electronic configuration. Okay, electronic configuration is about positioning the electrons in the right places. Likewise, the first concept we had KLMN, which is in class 9, 10. Now we will have then in 11, 12 we get SPDF configuration. We'll again repeat this, as this is the first class of theory. Suppose for S orbital, you can have maximum of 2 electrons. For p orbitals, we can have maximum of 6 electrons. For d orbitals, we can have maximum of 10 electrons, and for f orbital, we can have a maximum of 14 electrons. Okay. So these are the number of electrons which can be filled in these orbitals. For s orbital 2, for p orbital 6, for d orbital 10, for f orbital 14. Now let us take an example. Suppose we will do the electronic configuration of, suppose suppose calcium, which is at number 20 position. What will be the configuration? First S1S2, then 2S2, then 2P6, then 3S2, then 3P6, then we will have 4S2. 4S will come before 3D. This is a big thing. We have studied all these things in class 11, 12. Why this happens? Why? You can calculate 2 to 4, 10, 12, 18, 20. 3P, after 3P, it should be 3D, but we have 4S. Why? What is the reason? The reason is the energy level. The formula of energy level of any orbital is n plus L. So for 4s orbital, the energy level is what? The value of n is what? 4. And for s, as we have find the value of L is 0. So 4 plus 0 is 4. And for 3D orbital, the value of n is 3, but the value of d is for d orbital, the value of L is 2, so the sum is 5. So as you can see, the energy level of 4s is 4 and the energy level of 3D is 5. So as 4 is less than 5, the energy of 4s is less than 3d, so the electrons will fill in 4s orbital first rather than 3d orbital. So that's why we have 4s here. So this is the configuration of calcium. Okay. Now we will take suppose iron, whose number of electron is 26, atomic number 26. What is the configuration? 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, then the remaining 6 electrons will enter into the 3d orbital. Now calculate 2, 4, 10, 12, 18, 20, 26. Done. So this is the configuration of Fe, that means in the which situates in the 26th position. So now we will see some exceptions. Likewise, the configuration of what? Chromium. This atom is at number 24 position. For this, 1s2, 2s2, 2p6, 3s2, 3p6, then what? 4s2, 3d4. Here is a problem. The formulas we have, the theory we have done, according to this is correct. But the thing is, there is a problem. 3d4 system, the number of electrons, the maximum number of electrons in 3d orbital is 10. If we divide it by 2, we will get 5. So if we have to complete the half fill situation of 3d orbital, then we will have to field another electron here, and where from it will come? From here. So the right configuration is 4s1 and 3d5. This is the right configuration of chromium. This is one of the exceptions of the n plus L rule. So if we take one electron from here, it will not get that much unstable, because 4s1 is the half filled situation of s orbital. As the maximum number of electrons in 4s is 2, so 1 is its half, so it's not get much unstable. Okay. Now another exceptional case is copper, which is 29th in the periodic table. For copper, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. It should be like that, but again that problem, one electron will go from here to here, and it will become Okay. Okay. Now we will complete the configuration here. So 3p6. Now how many electrons? 2, 4, 10, 12, 18. Now next is what? 3p6. Then we should have 3d and 4s. So in 3d we will have 10 and in 4s we will have 1. So this is the configuration. This is the right one. We should have given here 9 and here 2. But for the same reason, to complete the fulfill stage of 3d orbital and to gain more stability, we will give 1 electron here and it will become like that, 3d 10 and 4s what? 1. So this is the configuration. Now we will take a larger atom. Or say platinum. The atomic number is what? 78. For this atom, 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, 3d10. Done for the first 30 atoms. Now electrons. Now after 3d we have 4s done. We will have what? 4p have. We have 4p, then 4d, then 4f, then you have 5s, 5p, 5d, then 5f, then what? 6s, 6p, 6d, 6f, dot. What is the value of, what is the energy level here? 4 plus 1, 5. So this is the energy level, 5, then 6, then 7. What is this? This is 5. 4s, 5s means 5 plus 0. 5 plus 0, this is 5, this is 6, this is 7, this is 8, again this is 6, 7, then 8, 9. Okay. Now compare these. The least is 4p. So next is 4p6. Then we have 6 here and here. And also here 3 6 are there. As the value of n is smallest here, so this will come first. 4d 10. Four p6, 4d10. Okay. Now after this 4d, then we will have 5p, because 4d6, 5s5. So before 4d we will have 5s actually, 5s2, then 4d 10, as 5s is what, 5, no more 5 there, now 6 is the least possible value is 5, 4p, and then another 5 is 5s, no more here, so 4p will come first, 4p 6, then 5s 2, 5 khatam. Next 6, what are the 6? There are 4d 1, then 5p, then 6s, no more, 4d will come first, 4d 10, now 6, 5p 6, then what, 6s2, now 6 done, now 7, the first one, then second one, and this is the third one. The first one is 4f 14, then 5d 10, then 6p6. Now count how many electrons done, 30, 36, 38, 48, 54, 56, 70, 80, 86. We have only 78, so this is not necessary, and here are only 8 electrons remaining. So this is the configuration of platinum. This is very important, this part. It will help you for in various cases. These things we will have to write and then fill the electrons. These will help. You can take the screenshot. Now I will give you some homeworks. Do the configuration with electronic configuration of atomic number. Suppose elements having 92, then random, I will give random 67, then what, 56, then 35, and last one 13. Do these in your home, the electronic configuration of these elements. Thank you. Today we will stop here, the first class.